Good morning, mathematicians. Welcome back. Spectral sequence time. Spectral sequence time. Always spectral sequence time. And you may think that this is me being late on a Sunday. But in fact, if you notice what time it is for me, I've experienced a time change. So, you can regularly, if you did not experience a time change in your region, you can now expect all of my live streams to be an hour later than usual. Okay. What am I thinking about today? Oh yeah. I watched this interview with Peter Schulze. And yeah, he was talking about when his Pro Etal site paper first came out. And apparently Dustin Clausen mentioned to him later on that he was kind of disappointed that Schulze would write such a boring paper because he didn't see the point of it at the time. And Schulze also said he didn't. Hi, good morning, Mom. Love you. Thanks for joining. And I mean, apparently Schulze said at the time he also didn't think that the paper would become as impactful as it did. But that's just, I don't know, that just goes to show you how crazy advanced these people are above, like, all other mathematicians. The fact that, Dustin saw that paper and was disappointed because it was boring. Whew. Crazy. Okay. So, where were we here? I think we had gotten down to about here. Yeah. Oh, we got to change the page thing. I don't know why some PDFs do that automatically and some don't. Which paper am I talking about? Schulze's the Pro Etal site. Pro Etal site paper. I can probably even find the interview for you. Yeah, it was this interview here. Somewhere in this interview. Okay, so where were we though? Typically, a spectral sequence is as interesting as its limit, especially if some fortunate circumstance causes it to collapse very soon. It is not too uncommon to have situations... Right. Where is my double complex? We promised spectral sequences could be used to compute the cohomology of the total complex. We'll now see how a double complex gives rise to an exact couple, and therefore a spectral sequence. Okay, we're doing descending filtrations. Right, that's what we did before. For example... And then we formulate the graded thing. We will assume that this is an object of the same category for simplicity, although this is not necessarily the case. Abelian categories are not necessarily closed under infinite direct sums, since only finitely many objects will be involved in any specific computation. This plays no role. Okay, we got our double complex. And we're going to ask that this double complex anti-commutes. Right, so maybe I should write that. What's the total complex? That's probably just the sum along the things of the total degree, right? But let me just double check where total complex is, just to be sure. Oh, what am I doing? Total complex. Oh, we gotta go back a little bit. It must be what I think it is, but better safe than sorry. Yes, it is exactly what I thought it was. Schultz's writing really makes it sound like he's just trivially rephrasing Falting's work. He's too humble about it. Yeah, that's true. Actually, I don't know why I said that's true. I don't know that to be the case. To be honest, I'm not intimately familiar with a lot of Schultz's writing, but I could believe it. I found the interview with John Tate, his Abel Prize interview, to be extremely annoying because he has the most cited. I don't know if this is true, but probably the most famous PhD math thesis, and and he's just like very annoyingly humble about it, and it's like, okay, like. It's good to be humble, but it's also like, man, have some perspective. Like, it's kind of annoying for you to downplay your work that, like, whatever. Okay, diagram anti-commutes. So differential of the total complex will be dH delta V. Okay, anti-commutes. So, right. What does that mean exactly? Yeah, I guess that means we pick up a minus sign, right? dH del V is minus del V dH, right? Okay. Oh. He even gave the total complex definition again there. I didn't need to go searching. And I didn't need to go searching because I already knew what it was. But, it's good to be paranoid about these things. This complex admits at least two filtrations. The horizontal filtration and a vertical filtration. Well, I think I need to take a break from this series for a couple of reasons. One, because, it seems to be not that my live streams are all about getting the most views, but it's really you can see the view count is steadily dropped from pre-spectral sequence viewing. My other normal office hours definitely are all much more viewed, probably because they're more general, and I yap about more general stuff. Parallel and probably a very deliberate Probably a very deliberate choice. I mean, given that he is cracking jokes and making puns here and there throughout the rest of the book. Probably deliberate. Very deliberate. Or no, yeah, I guess maybe not. Maybe it is just accidental. He should have said perpendicular. Probably if he was being intentional, he would have said perpendicular, actually. Yeah. Okay, the vertical filtration is defined by chopping that off. Okay. Now this is a slightly different thing. The vertical filtration. So T dot M, the vertical filtration, is given by TKM being the sum over all I and j equaling k, with I being bigger than m. Okay. We denote the corresponding graded object, GRV dot T. Schulze needs to be humbled? Well, I don't think that's true. I think the problem is that he's far too humble for being like one of the greatest mathematicians currently walking the earth. As far as I'm concerned, he could be a lot more full of himself, and I would have no complaints. We denote the corresponding graded object. This to record the fact that it arises from the vertical filtration. Explicitly, the term of filtration degree M is that thing. Okay. Maybe I'll just write that down as well. GRVK T TKM TKM plus 1, which ends up being isomorphic to M K minus M. The differential induces just the vertical differential on the graded piece, since dH is 0 modulo the next piece of the filtration. I see. The modules on the original array can therefore be labeled as follows. What? The modules on the original array can therefore be labeled as follows. I see. Right, because those are all exactly these things. Okay. So this is right. Right. I see. Yeah. Most interesting. Most interesting indeed. With dashes connecting pieces of the same degree. The filtration on T also determines a filtration on the cohomology. Okay. We can also take the cohomology, or the mth filtration on the cohomology to be the image of this in here. Okay. Right, I guess we just have the inclusion of these two and then we apply cohomology. And it's all injective, maybe? Or maybe not, maybe it doesn't matter. Thus, we also have the graded cohomology. Thus, we also have the graded object. Okay. And this is an interesting take. I remember reading this before. I don't quite totally understand it, but spectral sequences help us understand the relationship between the cohomology of the vertical grading of our total complex and the grading of the cohomology, also coming from some vertical thing. Have to meditate on exactly why that's the case. But great. Well, mind you, perhaps I don't have to meditate too deeply, and Aluffi will explain it to us. Right. So the monomorphisms define maps here, of which the grading thing is the co-kernel. And so we have this exact sequence. Right. Oh, and that's where the exact couple is coming from. Okay. Okay, I kind of want to write this down. I feel like it'll help me remember these things. So the inclusion induces the sequence and this is our and since, as we know, since 3.3 this determines an exact triangle. Wait, since 3.3, where's 3.3? Oh, right. No, this is just the long exact sequence in cohomology, basically. And then you sum up the cohomologies, right? Interesting. Very interesting. So what do we get? The cohomology of HMT. Oh, I drew it too big. It's not going to even fit on here. Right. So gamma is like the connecting homomorphism. And T dot M alpha. Nice. Okay. Great. Oh, I wonder, now that my preprints are out, and my thesis, I basically just need to staple those together and edit them. Maybe I should start doing, maybe I could start doing like, streams, live streaming myself editing the thesis, like a study with me stream. Someone was suggesting that before. I could maybe start doing that. And then also you know, studying background material for my defense. Yeah. Could be good. Could be good. Okay. Note that alpha decreases the filtration degree by 1. Okay. Alpha. Right, because alpha comes from here. Alpha's just... Wait, how is that? How is that the case? Alpha's the map on cohomology induced by inclusion. Decreases the filtration degree by 1. Decreases the filtration degree by 1. This I don't understand. This I don't understand. So I have something here. I include it into here. Wait, the filtration degree of what exactly? Yeah, alpha is literally induced from inclusion of the filtration. I agree. But why is it decreasing? Oh, because you're viewing those elements in there. Sure. Yeah, okay. I was thinking, yeah, I was getting confused with the increasing degrees going down. Right. Okay. Yes, of course. Of course. All it's literally doing is just changing the degree that you're calling an element. Right. Leaving the cohomology degree k unchanged. Beta leaves both unchanged. Okay, leaving the cohomology degree unchanged. Yes. Beta leaves both unchanged. Beta leaves both unchanged. Sure. Yeah, I guess. Yeah, I mean, we're defining the graded thing just to be the quotient of those two pieces. Yeah, so it shouldn't change the grading. It shouldn't change the filtration degree there. Or I guess... Yeah. Yeah, the filtration degree should be the same. And what about why is the cohomology unchanged? Why is the cohomology degree unchanged? Because it's just... You're just taking the map induced on each piece of cohomology, right? So, is that the reason why? I think so. And gamma should increase both by 1. Yes, definitely, because it's the connecting homomorphism, it should increase cohomology by degree 1. Absolutely. Why does it increase the grading, the filtration piece by 1? That I feel like is a little bit trickier, potentially, because we're talking about some... you know, we're using our snake lemma map here. So, what is going on exactly? Why would it increase the grading? I mean, don't we kind of gotta track through the snake to see exactly how the connecting homomorphism should behave there? Like, I feel like seeing why that's the case involves writing out the diagram and tracking through all the co-kernel madness. I don't really feel like doing that right now. And it is explained to us. This is particularly clear if one draws a small slice of the sequence sufficient to see the connecting homomorphism. Nice, I called it. Sufficiency connecting morphism in action on a piece of a given filtration and cohomology degrees. Right. Nice. Okay. I guess it's not that bad. I guess you don't actually need to compute the connecting homomorphism. You just literally write out the diagram. Okay. So, the spectral sequence of the double complex with respect to the vertical filtration. The spectral sequence of the double complex with respect to the vertical filtration is the spectral sequence determined by this exact couple. Nice. Okay. We will denote this spectral sequence by VE with the absurdly positioned index V, recording that this arises from a vertical filtration. Horizontal, likewise, like that. All terms of VER of the spectral sequence are subquotients of the first one. So the first one being that. VE1 being H graded VT. The differential, right, the differential in this case acts by increasing the cohomological degree K by 1 and the filtration degree by R. Right, gamma is increasing by 1 and beta is like wrapping around R times or something like that. Oh, and then he goes on and says that right away. And after undoing beta, R1 times around times the effect of alpha. So it does not change K, but increases M by that. Okay. Interest in the sequence rests on the interpretation for its limit in the statement that follows, which also summarizes the situation. Theorem. Okay. Ooh, we're actually going to maybe go through the proof of convergence of a spectral sequence here. Fantastico. Yeah, see, this is the most dead Sunday I've had in a millennia. Especially seeing how late it is. Normally chat be popping off. I know I've been saying this for a while, but it might actually be time for a break soon. Just to have, I'm addicted to those views. So got to go back to ordinary office hours for a bit. Mind you, we're almost done. We're almost done this chapter anyways. So maybe we're near a natural stopping point. Good morning, Nerd Coke. Haven't seen you for a while. Welcome back. Welcome back. Okay. Waiting for the triality stream. Yeah. Maybe tomorrow. Maybe tomorrow we go through triality. Happy Dead Sunday. And happy Dias des Muerte. Although technically that's tomorrow, but I think I think it also is like a multi-day celebration. I could be wrong. Happy Dead Sunday, everyone. Anyone else drinking café au lait avec honey? Meal is honey en français, no? No, I drink it black, dark like my soul. Real man coffee. Yeah. Okay. I don't know what that was all about. Double complex in a Abelian category. And let T be the total complex. Then with notation as above, there exists a spectral sequence. There is a wasp in your house, so this is a perfect distraction. Why are you wanting to be distracted? You should be going and committing murder on the wasp, no? So there exists a spectral sequence such that the E1 page is isomorphic to the homology of the vertical grading of the total complex, and the E infinity page is isomorphic to the vertical grading of the homology of the complex, of the total complex. Okay. It's a lot to take in. I wonder, let me jump ahead to some of the exercises. I want to see some of the exercises. Now that I've understood it a little bit in Aluffi's words, we could also possibly turn to bot and 2, use it to prove, where do I have bot and 2 here? They definitely use it to prove some stuff in algebraic topology. Where's bot and 2? I didn't think I had it at the office. Gang, what's going on? I didn't think it was at the office. Oh no, it's right here. Maybe let's take a look at that in a minute. And where is cohomology of groups? Let's take a look at these in a minute. Mind you, bot and 2 I could bring up on screen. But let's also see these. Also, off topic, you'd love to see a collab of some kind between me and Math Life Balance. Yeah. I don't know what we would collab on. Maybe she could teach me K-theory in live streams. Could be. Probably she's far too busy for that, though. Hello, Fimno. Right, what are the exercises here? Quasi-isomorphism things. Whoa, what is going on? Okay. Proves that there's a cochain complex. Here we go, 9.8. Spectral sequence from an exact couple. I don't know how interested I am in a lot of these exercises, TBH. I mean, they're probably good for me. Oh, this is exactly what I want. 9.10. Abelian categories, additive functors, enough projectives, and some sort of acyclic condition. Let this be a Cartan-Eilenberg resolution of the complex as constructed in 7.9. Okay, I'd have to remind myself what that is. Now take double complexes associated with that to construct a spectral sequence to the horizontal filtration. Prove that the E2 term of the sequence has terms like this. Yeah, this is the growth and decay spectral sequence. Okay. Vikil also has some spectral sequence exercises I'd probably enjoy. Oh yeah, we could go over to Vikil. Have I heard about using filtrations to make a ring Noetherian? You have no idea what this means though. Just trying to get motivation to learn spectral sequences. You know, Noetherian is needed for sheaves. Well, I don't think Noetherian is needed for sheaves, but Noetherian is certainly a nice property that we like to have. Yeah. Make a ring Noetherian using filtrations. I mean, Noetherian is basically about some filtration collapsing, right? So how do you use filtrations to force a collapse? I don't know. No, I guess in short, I haven't heard of that. Okay. Let's get into this proof, though. And I guess we'll just review it. Probably absolute maximum will only go for like 30 more minutes. And probably less than that. So, we shall see. But I think we'll wrap it up here. Yeah, there's exercises. We'll come back. This won't be the end of the spectral sequences live stream, but I think we will take some ordinary office hours break. And I'll probably end up teaching myself some other things during those anyways. Okay. In other words, turning the crank moves the grating from inside the cohomology to outside of it. The limit does not quite compute to the cohomology of the total complex, as we glibly announced in 8.3, but it computes the graded object determined by a filtration on the cohomology of the total complex, and this is good enough for many applications. Okay. Proof. So the limit can be computed directly from the exact couple as a subquotient of this. It is this quotient. Yes. The computation is streamlined by focusing on a specific degree for cohomology and m for grading. The corresponding part in EV1 is the kth cohomology of this quotient. And alpha acts as this. Yes. Note that if R is sufficiently big, then this dies, and these are equal. Why is that true? Why is that true? Oh, under our boundedness hypothesis. Oh, it's explained right here. Right. Indeed, this is 0 if I is bigger than j, and this is equal to this for I less than 0. But the first of these observations, the piece sent by alpha r to this is 0 for r sufficiently large, and it follows that all of these intersections are 0. Okay. Therefore, z infinity is just the kernel of gamma, which is the image of beta. That's kind of trivial then, no? I mean, I guess we should be happy that it was so easy. But the second observation, the kernel has to stabilize eventually. Stabilizes to, right. The kernel of alpha r has to stabilize to the kernel of this thing. Sure. So beta infinity will be the sum. The union becomes the sum over all of these. Okay, I feel like I'm going to need to go through this more slowly and carefully later. Denote by new VM, I guess I should, V for vertical. VM is the inclusion here, the morphisms induced in cohomology by these morphisms, and sum all of these up. Then we get morphisms here. What? Okay. Sorry. What? We've got two morphisms coming out of this guy. Sure. I mean, agreed. But how do we... What does just saying you have two morphisms coming out of one object, how do you get here? How do you get that B infinity is just this? Oh, because I guess, I mean, if you believe that this is the sum of this, then this is just the kernel of V. But then what's the point of this part of the sentence here? That I don't understand. I don't understand what role this part of the sentence is even playing. But fine. Okay. But the innocent exercise 2.12, the image, this should be isomorphic to this. Oh, okay. And so I guess this is playing into, that's the point of it. It's playing into exercise 2.12 somehow. 2.12. Maybe we can go back and see what it said. Where is 2.12? Triangulated categories. Oh, I guess we should go to... Sorry, that would be here. Right. 2.12 says if you have morphisms in an abelian category, then these things are true. Okay, sure. Where were we? 692? as opposed to the suspect exercises, which you should never trust. Yeah. The exercises that have been convicted by the exactness of the original. Although just because they've been convicted doesn't mean that they're not innocent. Think about that. I almost finished the book. Yeah, well, it's a lot easier when you start when you start like 20 pages from the end. Pretty easy to finish a book then. How much do I think I understand in percentages of the content of this book? Probably most of it. I mean, well, it depends what you mean by understand. Like, could I go through and solve every exercise without looking up any definitions? No. But, I mean, I could probably teach a course on most of this. I mean, in fact, I did teach a Galois theory course using Aluffi. Maybe I would say I'm probably less familiar with these final chapters. Of course, I use homological algebra on a daily basis, but I would say maybe some of this stuff about the specifics of the construction of the derived category and stuff, like I could do with understanding better. And certainly the spectral sequences. I could not teach a course on spectral sequences at this point. Although maybe I could. You know, sometimes you teach yourself. You learn by having to teach other people. And then you really cram when you got a lecture on something. So by the innocent example 2.12, this is true. Okay. By the exactness of the original couple, the kernel of beta is the image here, which is the image of this thing. So we write that. And so finally, E infinity is just this. And that is exactly the vertical grading on this thing. Okay. Okay, this is definitely gonna require some redigestion at a later time, but seems believable enough. Theorem 9.5 is a substantial generalization of some other theorems. To see that it implies 8.12, well, let's see. Okay, let's go look. What's 8.9 and 8.12? 8.9. 8.9, let this be a complex, take a total complex. If star is exact, then the whole thing is exact. If each complex is exact, then the whole thing is exact. Okay. That's 8.9, and 8.12 is... What's the most sensational application of spectral sequences in other areas that improve understanding? I think, well, in algebraic topology, I think, you compute homotopy groups of spheres. The very first Fields medal was given to Serre. Really? That was the very first Fields medal? Was Serre? I didn't even know that. For his application of spectral sequences to studying homotopy groups of spheres specifically. Wow, that's like the hardest problem. Well, there you go. Let A be in a Abelian category and denote A prime The category of complexes. Okay. If this is a resolution, if star is a resolution of n in bounded complexes, then the total complex is quasi-isomorphic to n, and assume that the cohomology of each of these is concentrated in degree 0, then T is quasi-isomorphic to the complex of cohomology objects. Okay, that's quite the theorem. So, let's go back and look at that. Right. So note again that we have this with its vertical differential. The E1 term of the spectral sequence is the cohomology of this complex. That is the cohomology of the columns of the original double complex suitably shifted. If the cohomology of each column is concentrated in degree 0, then E1 is simply this complex. Hence, E2 is the cohomology of this complex, and higher differentials of the spectral sequence are 0 by degrees considerations. It follows that the sequence collapses at E2, and then that means that this is isomorphic to the cohomology of star. In this case, we clearly have this. So the conclusion reproduces the corresponding statement in 8.12. That is what is meant by the incantation by an immediate spectral sequence argument we mentioned at the beginning of the subsection. In general, spectral sequences are really just a computational tool, though. They're commonly used for computing cohomology K-theory. Whoa, Boris, you did get here just in time for the QED. You did. Wouldn't want to miss that. The thing about Arsenal is they always try to walk it in. So when is the segment when I talk about the Dodgers' miraculous comeback? Win in Game 7? Oh, no. Boo. I didn't know that they won. Boo. Boo. Like I said, I personally don't care all that much about baseball, but, my family certainly does, and I want them to be happy. And so I'm booing on their behalf. Yeah, Dodgers 5 ever? That's right, because it's not 4 ever. Because it's not forever. We'll get you next time. Hello, Pajama Man. Okay. The reasoning and other applications of the spectral sequence of a double complex are easier to understand if various degrees and shifts are visualized in a more compelling way. View this as an E0 term in the sequence. All horizontal definitions, differentials are dotted out to highlight the fact that this is obtained by taking cohomology of the columns, which gives us this. For example, the part in degree 2 of this is the cohomology of this here. This is making me dizzy. So many indices. What is this? Differential geometry? Nothing is most anything in math forever, probably. That's my favorite sentence I've read in some time. Such diagrams are hard to parse. Amen. Amen, brother. To simplify dealing with the indices, it is common to assign degrees to the terms in here according to these indices at which the cohomology is computed. Right. Analysis is the most boring part of math. Whoo! Spicy takes from a rod. Spicy takes from a rod. You felt like this Specky series was targeted at you? You'll for real go rewatch the old streams when you get some free time. Yeah. So never. Yeah, when the pig fly. Yeah, when the pig does a moon landing. Rod, I gotta say though, you're definitely dangerously close to losing your little gear icon there. I will not accept. Consider this your warning. I will not accept analysis slander on this channel. Of course, deep down inside, I'm an algebraicist, but you know, I do have my love for my analysis homies. The ops will never catch you doing analysis. Ooh. Come on, guys. We can't have the slander. You can't have Langlands without analysis. What's the poset? You cannot apply Zorn's lemma. There should be a whole course called index theory. Yeah, there is a whole subject. Yeah, as a Rod says. Order theory is not analysis. You will not stand for this slander. Although you did just see a lovely proof that numbers theta whose distribution theta to the n mod 1 is uniform has full measure. You're just lashing out because it's being mean to you. Well, that's fair. That's fair. It's very human of you. The OG proof for bot periodicity uses mouse theory. You mean Morse theory? And nowadays all the cool kids do K theory. Yeah. Yeah. Speaking of, well, is that the original proof? Is that the proof that's in my K theory book? Where's my K theory book? My room is just littered with textbooks. There's textbooks lying around everywhere. Where'd I put the K theory book? Oh yeah, let's see. I don't think there's Morse theory in here. I could be wrong. Is there Morse theory in here? Let's take a look. You can all be thoroughly entertained while I read this book off screen. Yeah, I think this does the proof via Clifford algebras. Yeah, bot periodicity Clifford algebras, yeah. Yeah. May or may not get to that book at some point in time. Okay. Clifford the big red dog, exactly. Your room is just littered with textbooks. Bro gets paid too well for a broke grad student. No, I definitely... In fact, most of these textbooks were accrued before I was a grad student, when I had even less money. And yet somehow, you know, addicts always find a way. Whether that's textbooks or whatever else. So, yeah. This is like hipsters wearing Carhartt. Yeah, except, you know, when unlike hipsters, you know, when it's time to do Carhartt, they want to wear Carhartt till it's time to do Carhartt shit, you know. I actually get down and dirty with it. And I do it live. Exposing myself to all of you. Exposing my brain to all of you. You really wish you had more textbooks? Well, that is a solvable problem. That is an easy problem to solve. You've been considering getting textbooks again, even though you have PDFs of everything? Yeah. Yeah, I like physical books too. I do. But, you know, I also think about, there's some books I kind of want to get, but I'm like, well, I got to move. I'm probably going to move in like 8 months or something. So, yeah. You're scared to get more physical books. There's too many to choose from. Yeah. Well, Vakil's got his nice shiny new one though. So, I mean, most of the books that I haven't read most of them. Most of the content of the book. So yeah, I have that problem. Yeah, it's true. I do think having physical books is more motivating to go through them. Until you have to control F. Yeah, I don't know. Actually, yeah. I don't know. Sometimes, though, I find looking for something in a physical book is actually, even though you don't have control F, sometimes I figure it's, I don't know, it's easier somehow. You have Katani et al. Hodge theory. You got it for like $5. Damn. That's a hell of a find. I got this book on like homological algebra and mirror symmetry, and for like $1, and it's completely incomprehensible. And so I'm like, yeah, that's why you were giving away for $1. You're reading this weird ass topology. Chat to grad students. I think there's a lot of grad students here. Armstrong, yeah, I've heard of it. His algebraic topology section is so playfully weird. Even if you've already learned algebraic topology the right way. Interesting. Because universal algebra isn't as active as much anymore. Most of the textbooks, papers you find on interesting stuff are from the era of typewriter fonts. Oof. Yeah, you couldn't pay me to read one of those books. Actually, maybe you could. Send me money. I'll torture myself trying to read one of those awful textbooks on live stream. How about that? But you'd have to give me a lot of money. Okay, let's read these final paragraphs and then get out of here. Argument, sketch above, is probably clear from this point of view. Right, start off with the horizontal. Slowly go more vertical. Of course, spectral sequences are not limited to these simple applications. The Grothendieck spectral sequence computes the derived functor of the composition of two functors. For example, if these are two red exact functors, this sends projectives to projectives. Then there is a spectral sequence whose E2 term page collects the compositions and abuts to this. For instance, if this is a homomorphism of commutative rings, so that S may be viewed as an R module, A is an R module, B is an S module, and hence an R module for F, then there is a change of ring spectral sequence. Whoa. Tor PS, Tor QR, which collapses to this in R. Aha. That's interesting. What is the change of ring? That's very interesting. What's everything we can know about the change of ring thing? Because actually, I'm very interested in like auto equivalences induced from ring morphism. So I wonder what that can tell us. Stream is dying indeed. Stream is dying for you? Wait, what? Just taking more time to think. To be honest, you don't like going to books first. You prefer someone to spoon feed you first or watch a YouTube video. That's why I'm here, baby. Great strategy until you have to do research. Yeah, that's true. Picking up the habit of multiple sources more. That's good. Realize maybe a little late that lots of confusion is just poor writing or notation. Yes. Not even necessarily poor writing. Sometimes it's just a different perspective, you know. Sometimes you just connect to a different perspective easier. In topology, the Serre spectral sequence can be used to compute the homology of vibration. We already did that, gang. It would be completely futile for us to attempt to do any justice. Whole bunch of names. Many important spectral sequences may be derived as particular instances of the Grothendieck spectral sequence mentioned above. The reader will have the pleasure of seeing how the spectral sequence is put together by working out exercise 9.10. Yeah. Okay. Well, we will probably come back and do this exercise at some point in time. I really would like to understand it for myself. Maybe tomorrow. Maybe I still won't take a break. Who knows? Who knows? I don't even know. But I will know about the time that I hit start streaming tomorrow. Having good intuition can help prevent. But having good intuition can help prevent what's ahead? Huh? You meant that those YouTube videos or stuff just don't exist on that topic? Not yet. Not yet. I got to start doing, news, paper drop news. Yeah, maybe that could be a fun weekly segment, Look at archived papers and read some abstracts or something across a bunch of different fields. I don't know. I'm just spitballing here. There's a playlist by a mathematician popularizing algebraic key theory, short 10-minute videos. Ooh. You'll go to Hogwarts to do spells and shit, and you'll be fucking pleased about it. Yeah. Okay, I'm peacing out for real now. Thank you, everyone, for joining me. And, you know what I'm about to say? Q.